Reaction mechanism. Definition: a sequential account of each step describing details of electron movement, energetics during bond cleavage and bond formation, and the rate of transformation of reactants into products is referred to as reaction mechanism. That means step by step, each and every step explanation is nothing but mechanism. Okay, so how the reactant is attacking by reagent, and what is the intermediate, how the bond cleavage is takes place, how the bond formation is takes place. Okay, these all steps is, if we write clearly, that is only known as mechanism. Now here, species on which reagent is attacking is known as substrate. Suppose here this is the methyl chloride is there. This methyl chloride OH minus is attacking and forming methyl alcohol. Okay, so this OH minus attacking agent, this attacking agent is known as reagent. This is the reagent. What is the this main reactant? This is the reactant or substrate. Reactant or substrate. Substrate. Okay, reactant means main substance. So the attacking agents are called reagents. After that, the final, which is forming the new substance, that is called product. Sometimes beach may, here it is forming intermediate also. Here intermediate is forming X, Y, Z, then it is forming. So this one is intermediate. Intermediate. So all these steps explanation is known as mechanism. Now, type of cleavage of bond. Type of cleavage of bond. So here C bond Cl is there, suppose. How this bond cleavage takes place? Here two types of bond cleavage is there. See, one bond is indicating two electrons. You can see here C and Z. Z means any one atom. So one electron is Z electron, one electron is carbon electron. If these two electron, if it is shifted towards Z, so Z is getting negative charge. Suppose if these two electrons are shifted towards carbon, then carbon is getting negative charge. Obviously the other part will be positive charge. So this type of cleavage is called heterocyclic cleavage. Heterolytic cleavage, sorry. This cleavage is called heterolytic cleavage. So here ions are forming, that's why it is also known as ionic cleavage also. Heterolytic cleavage or ionic cleavage. Cleavage, another word is there, fission also, heterolytic fission, right. Suppose if the electron is exactly distributed equally, so that means the bond is cleaved half of, so each one is getting one electron, that type of cleavage is called homolytic fission or homolytic cleavage. It is also known as anionic cleavage. Anionic cleavage. Here each atom getting one electron, so this type of reagents are called free radicals. These are called free radicals. Okay, so total we are getting here three types. One is positive, one is negative, the other one is free radicals. Okay, so both the cleavage, ionic and non-ionic, is giving three types of species are formed, one carrying positive charge, the other carrying negative charge, And the third one, neutral with unpaired electrons, is known as reaction intermediates. Okay, these are reaction intermediates. These names I can write here. This one is electrophile, this one is nucleophile, this one is known as free radical. Free radical. Okay, these all are radicals only. Here, this single electron one is known as free radicals. Now, these three are attacking agents. What those are? Positive electrophile, nucleophile, and free radical. I am taking one carbon example. The species which attack on substrate molecule or intermediate and form a product is called as attacking reagents. These are attacking reagents. These are of two types. One is electrophile or electrophilic reagent. What is the meaning of electrophilic? Electrophilic. Electro means electron. Philic means loving. Electron loving. Why electron loving? Because these are electron deficient. Suppose here C plus is there, so electron deficient is there. Obviously, these are ready to take electrons. Okay, these are electron loving. The reagent which attacks on the negative of the molecule or love electrons are called electrophiles. Electrophiles may be positively charged or electron deficient molecules. Electron deficient, how to know that? Molecule with sextet or septet means which is having 7 electrons or 6 electrons. Okay. Now classification here, positively charged electrophiles. See, all positive charged, all I can write, all positive charged species are known as electrophiles. H plus, SO3, H plus, NO plus, NO2 plus, X plus, whatever, all these, all positive. Then, now here, little concentration you have to do. Neutral electrophile, in this neutral electrophile, electron deficient. How to know that electron deficient? Which is not following octet rule. That means less than 8 electrons, which are having less than 8 electrons. See here BF3, you know that Lewis acid, all Lewis acids. If you know the concept of Lewis acid, all Lewis acids are neutral electrophiles. So one example I will explain you, BF3. See here how many electrons are there with boron? Total 3 bonds means total 6 electrons. Okay, but 8 electron is the stable. That means still for octet 2 electron deficient is there. That means one empty box. It is ready to take electrons. So electron receivers are known as electrophiles. Electron loving electron receivers. Okay, next. The neutral atom that accept electrons from the substrate. Here some more electrophiles, neutral electrophiles are there. You can see here this carbon is following octet rule also, even though electrophile. Why? Because this pi bond is shifted to oxygen. Why? Because more electron negativity higher of oxygen. So carbon getting positive charge. If carbon getting positive charge, oxygen getting negative charge means of course now the carbon is ready to accept the electron from foreign species. कोई भी A minus, B minus, whatever. Okay. So here magnesium, this X means halogen. This electron taken by halogen. So magnesium is getting plus. Then you can see here whenever a carbon is bonded with multiple bonds, with highly negative atom like nitrogen, C double bond O. Okay, in these cases, this is also act as electrophile because this pi bond is shifted to nitrogen, pi bond shifted to oxygen. Obviously, this carbon getting positive charge. So these are our cases. See here, all C double bond O. This carbon electrophile, electrophile, all electrophile. The star indicates the atom that accept the electrons. Now, free radicals, carbene and nitrene acts as electrophile. Free radical also electrophile because suppose if I take CH, here free radical is there. See, you count the electrons, total how many electrons? 7 electrons. So for octet 1 electron required. So electron receiver, this is also similar to electrophile. The free radical also similar to electrophile. You can see here H radical, HOCl radical, these all. Now, nucleophilic reagents are nucleophiles. What is a nucleophile meaning? Nucleo means nucleus, phile means loving or attracting. Okay, which are attract nucleus. So what is the charge of nucleus? This is the nucleus, so positive charge. Positive charge, this some X is attracting the positive means what? It should be in the negative charge. So I can say now all negatively charged particles are known as nucleophiles. Okay, you can see example H minus OH minus OR minus, these all negative charged particles. As well, some neutral nucleophiles also present. Those are generally Lewis base. The last slide we explained that all Lewis acids are electrophile. What are the Lewis base means? Lewis base means which can donate electron pair. These are called Lewis base. So all Lewis bases are nucleophiles. So nucleophile, the common concept is electron excess, electron denser particles. Electron excess or electron denser particles. So here electron is not excess but electron denser, means lone pair is there, negative charge is there. In that case, those are acting nucleophile. What are the condition? One is negative charge, the second one is lone pair. Lone pair. Okay, in these two cases, these are acting as nucleophiles, and some other examples also you can see here. RMGX may, here in the last case we discussed Mg is the plus. If Mg is the plus, obviously R is the minus. Yes. So that's why this R is acting as nucleophile. Same cases when these metals connected with the carbon chain. So metal is generally positive charge, the carbon is getting negative charge. So these are acting as nucleophiles. Here special case lithium aluminum hydride and sodium borohydride. In these cases, hydrogen acting as nucleophile, it is releasing as H minus. It is a hydride ion. What is this? Hydride, H minus. In generally, H is always plus, but here this hydrogen is connected with metals. In that case, hydrogen is present as H minus, that is known as hydride. Here CH3 Cn minus. Okay, negative charge, here positive charge. Okay, so sodium borohydride like this. When carbon is connected with metals, in that case this carbon is getting negative charge acting as nucleophile. You can see R2Cu, R2Zn, R2Cd, cadmium. Okay, when butyl lithium hydride. Hydrogen is connected with metals. These are the nucleophiles. Now, in this nucleophile, some types are there. First one is ambident nucleophile. Ambident nucleophile. What is that ambident nucleophile? The nucleophile which have two sides of electron rich center, or in which two or more atoms bear an unshared pair of electrons. That means two atoms can donate electron pairs. So here if you take KCN, here C minus is there, so carbon also can connect with electron deficient particles. Suppose C plus is there, so carbon also can form the bond, or nitrogen also can form the bond. So here two donors are there, so these are ambident nucleophile. Example, Rx is there. If you take Cn, C minus, so in that case we will get RCN. At the same time, if nucleophile is if you take nitrogen, it is forming isocyanide also. Cyanide and isocyanide. Two possibilities are there. That depends on the condition. We will discuss in the next classes. One is KCN, the other one is AgCN. Okay, in case of AgCN we are getting RNC. In case of KCN we are getting RCN. So the conclusion is cyanide, it can form the bond with carbon or nitrogen. Now resonating structures are also ambident nucleophile. Resonating structures. See here, CH2 minus, carbon is negative charge, but sometimes due to the resonance, see the bond is shifted here, this bond is shifted here. So oxygen is having negative charge. So this oxygen also acting as nucleophile. So two possibilities are there. Okay, this one also comes under ambident nucleophile. Next, amphiphile. What is this amphiphile? The molecules containing a multiple bond between carbon and more electronegative atom can act both as electrophiles or nucleophiles. So here C double bond O is there. This oxygen acting as nucleophile, this carbon acting as electrophile simultaneously, both. C triple bond N, C plus N minus. This is the nucleophile, this is the electrophile. Electrophile generally E plus, nucleophile generally Nu minus. We are representing. Okay. Now final conclusion here, electrophile and nucleophile differences you can see here. Electrophile means accept the electron pair. Nucleophile means supplies the electron pair. Okay, of course it is donating electrons. It is receiving electrons. Electron deficient. Already electron deficient is there. This is the electron rich, electron deficient. That's why it is generally positive or Lewis acids. It is negative or lone pair is present. Lone pair. Attacking the points of high electron density. Of course, here positive charge means these particles are attacking wherever electron density is more. Okay. In case of nucleophile, attacks the point of low electron density. Here electron density is there. That's why obviously this negative charge will attack on the positive charge. Example, these are Lewis acids, Lewis bases in the case of nucleophile. Possess an empty orbital to receive the electron pair. Here possess an electron pair which is loosely held and can be supplied easily. Electrophile, usually positively charged species, usually negatively charged here, forms an extra bond with nucleophile, increases its covalency by 1 unit. The number of bonds are increasing here. Forms an extra bond with nucleophile. The next topic, electron effects, we can discuss in the next video.